Okay, so today we are going over the mid-chapter 6 review sheet. I'm not going to do every single problem, but I'll do a few of each of the sections. So this is the mid-chapter 6 review. First, I'm going to go over stuff that'll be on Wednesday's part of the test. So part 1 of the test is no calculator. And then part 2 will be with the calculator. So, let's see, I'm going to do number 4 and number 5 in the first section of 5 problems. I think those two are probably the hardest. We have 11 to the 2x plus 1 over 5 equals the square root of 11. And I want to rewrite the square root of 11 as a power. So 2x plus 1 over 5. 11 to the 2x plus 1 over 5 equals 11 to the 1/2. And then, now that my bases are the same, I can equate my exponents. So I have 2x plus 1 over 5 equals 1/2. And here I really have a proportion. I can solve it by multiplying both sides. I can multiply the 5 and the 2. So I get 2 times 2x plus 1 equals 5 times 1. So we have 4x plus 2 equals 5. Subtract the 2, 4x equals 3. Divide by 4. X is 3/4. Number 5, e to the x squared times e to the negative 15 equals 1 over e to the 2x. We're going to add our exponents here, so e to the x squared minus 15 equals e to the negative 2x. That takes it out of the reciprocal. And then now this is my critical step. My critical step over here was this one. I can set my exponents equal. Oops. You get x squared minus 15 equals negative 2x. Add the 2x to both sides. So we have x squared plus 2x minus 15 equals 0. What two numbers multiply to negative 15 and add to 0? X plus 5, or I'm sorry, add to negative 15, multiply to negative 15 and add to positive 2. And x minus 3, so x is negative 5 and 3. Next set of problems is rewrite as a logarithm. So rewrite as a log. So let's do, let's say number 8. 3 to the 2x minus 5 equals 29. So the base of our exponent is going to become the base of my log. So that becomes log base 3. And then what it's equal to goes inside the log, 29. And equals, now my exponent goes on the other side, 2x minus 5. So the log base 3 of 29 equals 2x minus 5. Number 10, the e problems always get us a little messed up. E to the x squared equals 6. So the base is e, and log base e is the natural log. So natural log of what it equals, of 6, equals my exponent, x squared. So the natural log of 6 equals x squared. The next set of problems, my phone just went out on me, is rewrite as an exponent. As an exponential expression. we're going to do, say, 13 and probably number 15. I'm trying to pick like the harder ones to do. Number 13 is the log base 5 of x minus 3 equals negative 2. So the log base is 5. What it's equal to is my x minus 3, and the exponent becomes negative 2. So I'm trying to keep the colors the same as the last slide. So we say x minus 3 equals 5 to the negative 2 power. Right, x minus 3 equals 5. X minus 3 equals 5 to the negative 2 power. And then, of course, we could solve for x in this case. But we're just asked to rewrite it, so we don't need to do that. And number 15, the natural log of 5 equals x minus 3 again. So again, the log, natural log, is e, right? Log base e. What it's equal to is its exponent, and then what's inside. So we have, so it's 5 equals e to the x minus 3. I'm going to go back and look at one of the easier problems just to help us remember why it is that way. Number 11 is the log base 4 of 64 equals 3. And this is because, this goes back to our because statements, because 64 is equal to 4 to the third power. So 4 is your base, the 3 is your exponent, and what is equal to is your 64. Okay. So that's the basis of why it goes the way it does. So if you get stuck on how to rewrite them, write out one that you know is true, and that helps you make sure that you have things in the right place, because both of these statements should be true when you check them. All right, the next one is evaluate expressions. I sometimes write in cursive on here because it makes less of a tapping noise. So let's just look at number 16. Negative 2 times the log base 4 of 4 to the x squared. So remember that this is two different things. This is negative 2 times whatever the log 4 of base 4 of 4 to the x squared is equal to. And remember that what this is really saying is 4 to what power is equal to what's inside 4 to the x squared, and clearly that has to be x squared. And now you have negative 2 times x squared, so negative 2x squared. And then if we look at, say, number 17, e to the natural log of 9, if we says equals question mark, and we rewrote this as a log, it's the natural log of what is equal to the exponent, the natural log of 9. And that's why the answer is 9, because they're inverses of each other. So really, we're just getting what's inside there. Number 18, let's look at number 19. The natural log of 0. Remember that the log, any base of 0 was undefined. We cannot raise a number other than 0 to a power and get 0. So that'll never happen. So is the natural log of any negative number is also undefined. Any log of any negative number is undefined as well. And let's see, The next says find the inverse. Let's see. Let's see, number 22. F of x equals 3 to the x minus 1. So the first step was to make it y equals 3 to the x minus 1. The second step was to swap your x and your y, so x equals 3 to the y minus 1. And then we rewrite as a log, in this case, because it's an exponent. If it was an log, we would rewrite it as an exponent. So again, this is the base, this is the of, and our exponent is what it's going to equal. So we get y minus 1 equals, the exponent equals log base 3 of x, and then we add 1, we get y equals log base 3 of x plus 1. This one is not in parentheses because it got moved over after we rewrote it as a log. And number 23, y equals, I'm just going to change it to y equals right away, 2e to the x plus 4. So we're going to swap them, x equals 2e to the y plus 4. And we're going to subtract 4. X minus 4 equals 2e to the y. We're going to divide by 2. X minus 4 over 2 equals e to the y. And then we rewrite our log. The base is e, so it's going to be ln, the exponent, and then here's our of part. So we get that y equals the natural log of x minus 4 over 2. And you can put it in parentheses or not. I would get in the habit, if there's a lot of stuff over there when you're rewriting it, of putting it in parentheses. That way you have them even if it's not necessary. So y equals the natural log of x minus 4 over 2. Let's do 2 where we rewrite the log as an exponent. Number 25, the log base 9 of x minus 3 equals your y. So I'm going to make it x equals the log base 9 of y minus 3. So we get the base would be 9, and the of is the y minus 3, and what it equals is your x. So we get that y minus 3 equals equals 9. I'm having trouble with my stylus right now. 9 to the x power, and then we're going to add the 3. So y equals, wait a second. So we have y equals 9 to the x plus 3. Okay, we're looking at 26. 3 natural log of x plus 7 equals y, or y equals, I'm going to change my x to y. I'm going to move it over to the side. X equals 3 natural log of y plus 7. It's more consistent with what you probably have written. I need to get my natural log of y by itself. And that's going to be minus 7. So x minus 7 equals 3 natural log of y divided by the 3. So x minus 7 divided by 3 equals the natural log of y. Natural log is log base e. This becomes my exponent. This is my of. So that's e y equals actually e to the x minus 7 over 3. So y equals e to the x minus 7 divided by 3. And that snoring you hear in the background is my dog. That's a picture of him snuggled up next to me, just for added info, because I can hear it in the background. Let's look at the next set. He's cute. He's old. Okay, evaluate the expression. These ones are pretty easy. I'm actually going to skip them and go to the graphing. I will do one exponential growth, and I'll do one log graph. So let's see. For each, we're going to identify growth and decay. We're going to state the percent increase and decrease. Kind of talk about all those things. So we're going to do number 35 because it has some good transformations in there. 2 to the x minus 5 minus 2, y equals. So this is going to be growth because our b is greater than 1 and a is greater than 0. A is positive. Whenever a is negative, it's neither. Then this is a percent increase or decrease. So it's how far away is my base? B is 2. It's my growth factor. And my growth factor is 1 plus the rate or percent increase decrease. So my percent increase is 1 or 100%. So 1 or 100%. The growth rate would be 1. The percent would be 100%. So that's A and B. The domain and range. So our domain for all exponentials is all real numbers. And our range is normally y is greater than 0, but this has a transformation, right? This has a horizontal translation. That's the 5, right? 5, and a vertical translation down 2. That means my range is y is greater than -2 because it moved my asymptote from 0 to -2. So the equation of the asymptote equation is y equals -2. It must be written like this, y equals. It's not an equation if you just say -2. We already described the transformation from the parent graph here. And now let's actually graph it. We're going to make a table, -1, 0, and 1. When I do this, I prefer to just plot the parent function. So I'm just going to use y equals 2 to the x. I'm going to ignore the transformations, and I'll just move everything over. So 2 to the -1 is 1/2. 2 to the 0 is 1, and 2 to the 1 is 2. And each point is going to move right 5 and down 1. So when we graph that, and I have, let's see, I'll put my original points here, -1, 1/2, 0, 1, 1, 2 in green, and then I'm going to translate them in blue. So this goes over 1, 2, 3, 4, 5 to the -4, or to the +4, and then down 2. So I'm at 1/2, and so that should be -1.5. So I'm going to go -4, and then down 1/2, 1/2. Here's my first point, and my asymptote is at y equals -2. It kind of helps to just draw the asymptote first, so you can make sure everything stays under it. My green point is going to, or my 0, 1, 1, 2, 3, 4, 5. So that's at 5, and then down 2 should be at -1. So that's here. And then the next point at 1, 2, it's going to move over 1, 2, 3, 4, 5. So it'll be at 6. Down 2, we'll put it at 0. And then we know it's growth. So it looks really sloppy. Clean that up a little. Like this. Okay. So that's how I prefer to draw it. I prefer to look at only the parent graph, 2 to the x, plot those points because it's really easy to fill out the table that way, and then use my shifts. Now, if I was graphing, say, number 36, let me do number 36. 4 times 5 to the x minus 3. I'm going to make a table for 4 times 5 to the x, and then I will shift everything down 3. So let's make our table. Well, first let's talk about all of this. B is greater than 1, and A is positive, so it's growth. My B is 5, so that's my growth factor. That means my R is 4, which would be a 400% increase. The domain, again, is all real numbers. And my range would be greater than 0, but this translation is down 3. So y is greater than negative 3, which means my asymptote is y equals negative 3. That's my asymptote. And then my transformation is a vertical stretch factor of 4, then a vertical translation down 3. So we'll make a little table. For space, I'll do it horizontally, negative 1, 0, and 1. When I plug in 0, 5 to the 0 is 1, 1 times 4 is 4. When I plug in 1, 5 to the 1 is 5, 5 times 4 is 20. And 5 to the negative 1 is 1/5, times 4 is 4/5. So we'll graph that, and everything's going to get translated down 3. So I'll draw my asymptote here at y equals negative 3. And then goes pretty high up here because it's 120 and 0, 4, and then negative 1, 4/5. And then everything gets moved down 3, so we're at 4/5. 1, 2, 3. This point moves down 3, and this one moves down 3. It's really steep because of the vertical stretch, and it still doesn't touch my asymptote. Okay. I mean, we're not going to mark you off if your graph touches it, but if it crosses it, we will probably take some points off. So you need to make sure that when you draw it carefully and don't cross that line. Okay, now let's look at one of the log functions. I'll do 39. The log base 2 of 4x plus 3. So when I make my table, I'm going to only look at this, and I'm going to deal with the horizontal translation left 3 and the horizontal shrink factor of 1/4. And I said that, no, that's right. So there's my transformations. With the log, we don't talk about growth or decay, so this is neither, which means there's no percent increase, decrease. The domain is affected, though. The domain is normally x is greater than 0, but this translation left 3, right? The translation left 3 converts it 2x is greater than -3. So this is my domain on this function. My range is all real numbers. And so that makes my asymptote x equals -3. It should be an equation, and it should make sense. Like, look at your domain. The domain is restricted, x is greater than -3, and your asymptote is x equals -3. That's where it's not going to touch. Like, they correspond with each other. X equals y and y. And I describe the transformation. There's the equation of my asymptote. Let's make a table. So this is one. We're going to do the log 2 of 4x, where one of the ways we did this was we plugged in 1, 0, and -1 for the y. And we said, okay, well, log 2 of what gives me 1? Well, in this case, it's really 2 to the y equals 4x. I can rewrite it as an exponent, and then I can plug in my y values. So 2 to the 1 equals 4x. That's 2 equals 4x. Divide by 4, x is 1/2. And then we can say 2 to the 0 equals 4x. That's 1 equals 4x. So x is 1/4.